Okay, welcome to this talk on microservice patterns implemented by Eclipse MicroProfile. My name is Ivar Grimstad. I'm the Jakarta EE developer advocate at Eclipse Foundation. And today I'll take you through a bunch of microservice patterns and show how it's done with Eclipse MicroProfile. So this is my Twitter handle. Feel free to contact me there and tweet me whenever you want. I'm a member of the Java Community Executive Committee. I've been there for almost 3 years. Currently, I'm the alternate representative for Eclipse Foundation there. So I'm involved in the JCP going on as I've done. I'm also involved in the Jakarta EE Working Groups, where I'm in the specification committee, and I'm also in the PMC for the E4J project, which is the projects where the technologies for Jakarta EE is developed. As I said, I'm a developer advocate for Eclipse Foundation. I'm a Apache NetBeans committer. I run a local Java user group in Sweden, in Malmö. And I'm a Java champion. And as I said, feel free to tweet me if you have any comments or questions or anything. So MicroProfile, who here is using MicroProfile today? Okay, who has never heard of MicroProfile? Couple, good. And who's using Spring Boot? A lot of you, okay. So MicroProfile is an initiative to optimize the set. We're creating microservices using Java EE technologies or Jakarta EE technologies. So we will, I'll show you here how to use Eclipse MicroProfile to do most of the same thing that you would do if you're a Spring Boot developer. So you would feel familiar here and see that you can achieve the same things using standard technologies using Eclipse MicroProfile. And as you see, it's called Eclipse MicroProfile, and that is because it is an Eclipse project. And so it has the Eclipse name in front of it. But and at Eclipse Foundation, you can find all information of who is involved, who is working on it, how it's going on, what the releases. It's currently 3 releases a year, so every 4 months you have a new release of MicroProfile. So here is where you can find all information about that. You can figure out how to join it if you want to contribute to the project. MicroProfile is a set of specifications or APIs, and they are based on well-known Java EE or Jakarta EE technologies, such as CDI for context and dependency injection. We have JSON-P for JSON processing, JXRS for RESTful endpoints, and JSON-B for JSON binding. So these are the base technologies from the Java EE platform that you can use to build microservices using MicroProfile. On top of these, there are, in the current version in the platform of MicroProfile, there is 8 specifications on top of that. And I'll demo all of these using the context of microservice patterns. And as I said, the MicroProfile is specifications, and that means that you have a wide variety of implementations to choose from when you want to run this. So, for example, you can use Thorntail or Quarkus from Red Hat, OpenLiberty or WebServer Liberty from IBM, Payara from Payara, or Apache Tommy from Tommy Tribe, Helodon from Oracle, etc. There are lots of implementations out there that implements parts or some version of MicroProfile or the entire thing. So this is kind of the advantage of going for a technology platform where you have multiple vendors cooperating. So when you have these set of APIs to develop your applications with, you can freely move from one implementation to another if you see some advantages of doing that, or your company has some contract or a licensing deal with some of the vendors. You can move between them without actually changing your code. And that's a big advantage. And it also supports the jar-based deployment if you want to do that. So what I'll be doing here in the demos is I'll generate jars based on this. And if you come from the Spring Boot world, this is no big deal. You do it all the time. If you come from the Java EE world, we're used to creating WAR files with our applications and deploying them into an application server. But MicroProfile, the vendors here, are chosen to give us this tooling to create the jar files and run them from command line. There are other ways of doing it as well, and there are better ways of doing it, especially if you're running in a containerized environment. You probably don't want to package everything into a heavy thick Uber jar. You just want to have your application logic in a thinner layer and have your kind of application server implementation in the Docker image or container in some other layer. But as I said, it's a set of APIs, and we'll be focused on the programming model and the APIs here in the context of microservice patterns. So how do we get started with the MicroProfile? Well, there is a web page called microprofile.io, and that's where you go to find the information about MicroProfile. You see it was a Duke's Choice Award winner last year. This is an old screenshot. The latest version is actually 3.2, but I'll be using 3.0 to demo in this talk. And the best way to start with MicroProfile is to use the starter. So we have a starter page where, similar to the Spring Initializer, you go in to start microprofile.io and you can generate your project. And I'll actually do that when I start the demos today. And that brings us over to the patterns. So the patterns I'll be covering today are these. It's externalized configuration, health check API, application metrics, circuit breaker, access token, distributed tracing, and API description. And let's start with externalized configuration. And the problem statement for externalized configuration is how to enable a service to run in multiple environments without modification. So you want to configure a service without rebuilding it. So you build your jar or your artifact once, and then you move it to different environments, and it will behave according to how the environment is configured. So if you move it to a test environment, you want the test configuration. If you run it on a local laptop, you want the local configuration. And you don't want to rebuild your artifact, you want to use the same one. And we have, to do that, we have configuration for MicroProfile that helps us with that. And with that, it comes with 3 default configuration sources. You can use the application configuration file within your application in the MicroProfile config.properties file. And this is good for when you're just exploring things on your laptop and running in a local environment. You can just use the built-in configuration file. And then you can, when you put it in a Docker image, you can set the environment variables there, or you can read system variables from the environment you're running in. So you can set either system variables or environment variables in Kubernetes, for example, and the application will pick it up and override whatever you put inside the application. And of course, you can create your own configuration sources as well. So if you're having your password, for example, in some secure storage location, you can write your own configuration source that just picks them up there and injects them into the application without having to expose the passwords. And the externalized configuration for MicroProfile is implemented by the config specification. So let's go into a demo and show how this works. And to do that, I'll actually use the starter page. So you see here, it is a starter. I'll brief it up a little. You can go into the starter, which is start microprofile.io. And if you're used to Spring Boot, you'll see it's very similar to how you would do it there. So let's just create this one and call it DevOps Talk there. And here you have some choices to make. So you choose which version of MicroProfile you want to run on. And if you choose one of the previous versions, you'll see that you have a lot of different implementations to choose from. And this list will change depending on which version you choose. So I want to run on the latest one, so I'll choose version 3.0. And here I have 3 implementations currently. And as soon as a new vendor has their implementation ready, it will pop up in this list and you can use it. So let's try with Helidon. And you can also here choose some example code, so you will get an example for how to use the different specifications. I won't do that now for this one. I'll just go ahead and write it myself. So you click download, you get a zip file, and let's unzip this file and open it here, and open it in the IDE. So there we are. So it's loading my project, and as you'll see here, it has generated a POM for me. It's based on Java 1.8, but let's feel a little bit adventurous here and say that we are on 13. And since I chose the Helidon, I got the Helidon configuration in my POM file for me here, and it just defines how to package the application. So if I go in here, I'll just compile this one package. There you go. And while it's compiling, I'll just open the code and see here you have a hello controller that says hello world, which is not very exciting, but let's just start this one and see. There we go. So you see it's a jar generated for me. And it starts up pretty fast. You see it's in like 100 milliseconds to get started. And I can go into the demo, and I get the JAX-RS endpoint, which is hello world. So this is the starting point using the MicroProfile starters. You see, it takes me like 1 minute to get up and started, plus 111 milliseconds to start the server. So let's go in and add some configuration here. So if I go in to my class and say that, hey, I want to say something else. So I'll just add inject a property here, which is a config property, and I'll call it name equals and the place where I am, and let's also call that a string place like this, and rather than hello world, let's say hello to this place. And to configure this, I'll go into the configuration file and configure it for my local environment, and just add a property here called place equals devox, like this. And if I now just rebuild this application and run it, it should pick up this property from this configuration file. So let's. There it's up and running, and if I refresh now, it should say hello devox. So what if I want to move this to another environment and configure it without rebuilding it? So I'll just stop it here, and I'll say that I'll have a system property called place equals Antwerp, and just restart the application. And you will then see that it picks up the configure property. So this is how you can configure this application without rebuilding it. So that is externalized configuration. So let's move on to the next pattern, which is health check API. And the problem statement for health check API is how to detect a running service instance is unable to handle requests. And to help with that, we have MicroProfile Health API. And the health API is implemented by the health check. And let's demo that one. And to do that, I'll use another implementation. So I'll go back to the starter. And for this one, I'll choose Open Liberty. And let's call this Devox Talk 2. And download this one. So we're here, and let's open this in the IDE. So let's see where it's coming. There we go. Let's maximize this. And let's look at this one. As you would imagine, this is exactly the same application. So it has this simple Hello World controller. But this one has the tooling from Open Liberty. And here as well, let's say we want to run on 13 because we are newer there. So if I go in here and build this one, sorry, there. So this one will be the exactly same application. So you see, I can move the code from one implementation to another, and I'm just using another implementation to build this for me. And in this one, it is included the Liberty Maven plugin, which has some cool developer features for me. So it's building here. So rather than running it from command line, I'll run it using the tooling provided for me. So I'll use maybe in Liberty dev mode. So it starts up Liberty, and this one is also pretty fast. So it should be up and running every second now. There we go. So this one is on port 8181. So let's log into localhost 8181 and see it has the same Hello World endpoint. So let's start to add health checks to this application. And by default, from the microprofile, I have oh no, it's not hello. It's sorry, it's health. Health. There we go. So I do have a health check that comes by default. But as you know, when you go into a Kubernetes environment, you want two health checks. You want the liveness probe to show that your service is live, and you want the readiness probe to show that your service is ready to accept traffic. So let's add the liveness test and the readiness test to this application, and let's add a liveness probe. So what I got here is a class that implements health check, and it's annotated with @liveness. So by doing that, I'm adding a liveness test here that has the text Duke is alive. So if I go in here and say health/live, you'll see that Duke is alive. So this is how you add a liveness probe to your application. And it's exactly the same way if I want to add a readiness test. There we go. So here I can use the @readiness annotation, and it will give me a readiness probe for me. So as you see, Duke is ready. So this is how easy it is to create the health checks with microprofile. It's you implement the health check API and you annotate it with the kind of health checks you're using. And the global health check will now have both the health checks you've added. So I have Duke alive and Duke ready in /health if you want to use that one. So then let's move on to application metrics. And the problem statement for application metrics is how to understand the behavior of an application and troubleshoot problems. And to help us with that, we have microprofile metrics, which is implemented by the metrics API, which is part of microprofile. So let's look at how this is done. So in this application I got here, I haven't added anything about metrics, but if I go in here and look at the /metrics endpoint, you'll see that I have a lot of Prometheus metrics generated for me. And these metrics are of the type base metrics, which are specified by the specification. So if I move to another implementation, I can rely on these metrics that are there. So I don't have to change anything, even if I switch vendor of my underlying application. And there are also some vendor-specific metrics if you want to check something that the vendor provides for you. But let's see how we can add some application-specific metrics, which is more interesting for us, because we can use metrics to have business sort of metrics. So say that this Hello World service, I want to know how many times is this invoked. So I add the @counted annotation to my Hello service. I can go in here and I can invoke the Hello World endpoint again, do it a couple of times. And then go back to the metrics and maybe filter these by application metrics. And you see, hey, I've hit the Hello World endpoint 5 times. If I go in here, refresh this page, it will be 6. So this is how easy you can add business kind of metrics to applications. There are other metrics as well that are counted. You can have like metered and check how much time is spent in each invocation and stuff. And it's not limited to the REST endpoints. You can use it wherever you want in your application. So any method or class can be annotated with these annotation metrics, and you will be able to monitor them using for example, Prometheus. So the circuit breaker. So the circuit breaker problem statement is how to prevent a network or service failure from cascading to other services. And you know circuit breakers from your home, that if you run your dishwasher, washing machine, micro oven and want to make an espresso, then probably the circuit goes if you've wired it wrongly in your kitchen. And that is to prevent your house from burning down. So the concept applies also to microservices. If one service is going down somewhere, you don't want the other services to go down as well. You just want your application and the end user experience to be there. And circuit breakers are implemented by the fault tolerance specification from MicroProfile. And I'll show a little bit of this specification here. So if I'm in my application here, I have this hello world method. Say that I want this method to time out if it runs more than, let's say, if it runs more than 500 milliseconds. I think it's, what's the timeout value? I think I can just say value is 500 milliseconds. Then I want this service to do something else. So currently it's pretty fast, so it won't time out, so it will still say hello world. But say that this one is a very slow running service. So I'll just add a sleep statement here for 700 milliseconds. And if it sleeps for 700 milliseconds, I'll just return something else. I can print interrupted here. And what I can do is to add a fallback for this timeout. So if it times out, I want something else to happen. And I can add a fallback method that I call just fallback. And I can then have a method here, public, string fallback. There. And I'll just return something else. So return too slow. Oh, sorry. It's hard when these desks are so steep. So I'll just return too slow. So I don't know if Liberty fixes this, but let's see. So if you go in there, I just have to restart it, I guess. Or let me see. There you go. Too slow. So what happens here is that I slept for 700 milliseconds and the timeout was 500. So that's why I got the default method, which is too slow. So if this one is less than 500, then I would get it's really hello world. So this is how easy you can kind of set a timeout on a call and a fallback if it's not working. And this can also be applied around this system. It doesn't have to be on the REST endpoint. And this is just the timeout and the fallback. You can also have retry. So to set that if it times out, you want to retry 3 times and then go to the fallback. So there are a lot of flexibility here in the circuit breaker and the fault tolerance specification. So access token. And that is how to communicate the identity of the requester to the services that handle the request. And let's just go through some security concepts. You have the basic authentication, which you are probably very familiar with, which is basically a hash of your password sent in the authorization header of your HTTP request. And it's authorization : basic and then a hash of your password. And this will be sent with every request, and it only contains your password. So you will know the identity of whoever it is, but you won't know anything more than that. And it's not very secure. So for OAuth, it's kind of similar. Rather than authorization basic, you have authorization bearer, and you have a little bit stronger encryption on your password, but it's still a password being sent back and forth, and you have another password to refresh your password. So it's a lot of password around, but it's kind of handled by the application, so you don't have to think about it. But the mechanism for doing it is exactly the same. And it only gives you the identity. It doesn't give you any more information. So that's where JSON Web Tokens comes in. And JSON Web Tokens are technically exactly the same as the basic and OAuth. It's only you have a longer authorization header, and this authorization header is split into 3, separated by the dots, and you have a header. Which is a JSON base64 URL encoded, which gives you meta information about the token, like algorithm and type. And then you have the payload. Is the actual token. That is also a JSON. You have some standard entries and you have some custom entries. And at the end you have a digital signature that kind of validates that nobody has tampered with the payload in between. And in this case, you see you have the header, the payload and the digital signature, and a token could look something like this. You have the header saying algorithm is RS-256, and it's a JSON Web Token, and you have some custom and some required standard claims in the body of the token, and you have a digital signature at the end. And JSON Web Token propagation, the specification covers functionality for handling these tokens in your application. So let's go and look at this code. And to do that, I'll go to another application here. So I have here a secured service, which I'll open here. So let me go in there. So I have a protected endpoint here, which you can see I have a roles allowed annotation, which is from the Java's annotation security. So what MicroProfile has done is to define one of the custom claims as the groups that has to be in the token that translates into the roles concept of Java EE, so you can use Java EE security. So I can just annotate any method, in this case the REST endpoint, but I can annotate any business method in my application with the roles allowed, and the roles will be propagated from the token in the header automatically down here. So I don't have to do anything to to kind of configure that security concept. And also you can see here I'm injecting a claim value here, which I have called custom value, which is a custom value that this token happens to have, and I'll just show how that displays. So I don't have to parse any token or validate any signatures or anything. That's just handled for me by the underlying infrastructure. And what I said here is that I have a login configuration in my application, and I've declared one role, which is a senior, and that's the role that I'm using in my protected resource. So if I start this one, no, sorry. So let's see if it's running. No, I'll start this one. I'll also start a token generation service. So I can generate a token to see if it's working for me. So it's starting up now. Hopefully, let's see. So there it's up and running, and let's open this one. It was on local host 8282. Host 8282, and it's called just go to the root here. Wasn't it 8282? 8182, sorry. 8182. Did I write it wrong? Data. Let me just check here. I'll just go in like this. Data protect. Maybe I have a port conflict somewhere. Yeah, so I'll see if I have some other application running. I'll just stop these stuff so it won't conflict with me. And this one is stopped. Yeah, good. I'll just start it again. There you go. And this is up and running. So it should be up and running pretty soon. It's data just protected. So 182/protected should give me a 401, which is what I would expected, right? Because I don't have any token in my request. So let's see if I can log into this application. And I'll go here, use a token generation service, which I'm running here on 8183, and then I'll just do a post to this authenticate method. You see, I get a token here, and let's take this token and look at it. So I'll just copy it out there like this, copy, and I can go into jwt.io, where I can inspect my token. So if internet is with me here, let's just paste it in there. And you can see here that this token is a JWT. It has the group's senior, which is translated into the roles and roles allowed annotation, and also have a custom value called Duke Rocks. So that's kind of the content of my token. So let's use this in the request, and I'll just go into this header modification here and just add this token here. Let's edit like this. So I'm now adding a authorization header to my request, and if I go into the protected resource and refresh it, it just say protected resource custom value Duke Rocks, and so you see I can get this information from the token just by using these simple annotations. I'm injecting the at claim like this, and I'm just saying Duke Road senior, and you see it works. So distributed tracing. How to understand the behavior of an application and troubleshoot problems. And Zipkin is a tool that is usually used for distributed tracing. Jaeger is another. And you can do this easily by annotating your method using the Open Tracing Configuration API of MicroProfile. So let's look at how this looks. So I'll just shut down my security service so I won't have any problems with ports and stuff. And let's go into and look at how tracing can be done. So I'm not sure if this is actually going to work because it requires some other things running, but let's look at the code. So this is not going to get it. I'll actually just do the code I used in the demo. So I'll just start the Liberty dev. Oh no, that's not going to work either. Sorry. Let's try to get this working. So what I can do to do tracing in MicroProfile is to add the @traced annotation. So I can annotate my class or method or a part of the code with @traced, and it will send this stuff to Zipkin. So in this case, I'll have to uncomment this stuff because it's not going to work, I guess. So I'll just return a string saying hello. So what I'm doing here is that I've added the @traced annotation to my hello greeting method, and let's see how this one works. I'll just rebuild it. The reason why I cannot do this call is that I'm calling another service, and I wasn't able to set up that service running remotely. So the application wouldn't be able to call the other service. So and then of course I could use fallbacks for MicroProfile and stuff. But in this demo, I'm sorry I couldn't make that happen. But I'll demo the tracing here anyway. So I have a Zipkin instance running locally on my computer, which this application is set up to produce tracing, or is listening to tracing for this one. So if I run this one, traced jar, I'll just start it up and fire a couple of requests to the hello method, and we'll see if it pops up in the Zipkin console. So I have Zipkin here. So if I go and say find traces, it won't find any because I haven't been running any applications with the tracing annotation yet. So when this one has started, I can go into the root context here and say /hello. So it's invoking my hello endpoint. So I've hit it once here, and if I go back to and look at Zipkin and now say find traces, you'll see that it finds a trace here, and it says, "Hey, I've been doing this call to the tracedude service." And if I were doing service calls to other services, it will record the spans down there, so you can see the trace of your service being called from service to service and the amount of time spent in each service call. So the last one I'm going to show is API description. And API description is the problem statement there is which knowledge should be shared between an API provider and its clients. How should this knowledge be documented? And to do this, we have the OpenAPI specification of MicroProfile. And OpenAPI specification specifies how to that you can document your classes generating the OpenAPI 3.0 version that describes the services, which is read by Swagger, and you can use it to generate a Swagger client. So if I go in here and look at this hello service, rather than saying hello, I can go to OpenAPI. You'll see that I get a OpenAPI YAML file for this greet resource, which is /hello, and I actually also have here a UI for it, which OpenLiberty provides for me. So here you actually have a Swagger client to try out the application. So this is how you easily document your services. You don't document them. You just get it for free. But by just having the JAX-RS resource annotations, it will generate your OpenAPI Swagger docs for you. So no more documentation. So of course you can add your own annotations here using the MicroProfile OpenAPI specific one, or even Swagger annotate your endpoints if you want that to give proper documentation of your endpoints. But the simple stuff will just be generated for you. So to sum up, the microservice patterns have been borrowed from Chris Richardson, who's written a book of microservice patterns. He has a site microservices.io, where you can find information on all these patterns. And as you see here, the patterns or the API specification of MicroProfile maps very well into the patterns on this graph. And you also have the API description pattern, which is from microservice patterns out there. So you see the microservice patterns maps very nicely into MicroProfile 3.0. So the patterns I've gone through today are externalized configuration, health check API, application metrics, circuit breaker, access token, distributed tracing, and API description. And more information about these patterns are on microservice.io or microserviceapipatterns.org. The samples I'll be showing today are on my GitHub up there. And microprofile.io is a site for MicroProfile. Jakarta EE is the site for Jakarta. And that was what I had for today. So we have a couple of minutes left for questions. Anyone? Okay. Thank you very much for listening. And I have some stickers here, MicroProfile Jakarta and Eclipse stickers. So please welcome, come forward. And thank you for listening. And enjoy the rest of the conference.